So hi there and welcome back to my latest video, and I think I've got a really good video for you today. In this video I'm going to show you the one thing that I know a lot of people have been asking for, waiting for DICE to implement, and we could be waiting for some time before they do it. So I've got it for you here now, and that is how to set up your own custom area for capture on any map in Portal for Battlefield 2042. In today's video I'm going to show you the code that I have created. I'm going to go through a little bit of an explanation about how it works, but I'm not going to go into the code itself. What I'm going to do instead is I'm going to show you how to adjust the code that I've provided to create your own capture point. Hopefully for most of you, especially those that don't have a coding background, that will give you all of the information that you need. And obviously if you are a programmer and you want to delve into it a little bit deeper, I'm going to once again provide you with a link to the code so that you can dig a little bit deeper and use it yourself. I am going to use this code quite a lot in modes that are coming up. It does have some limitations which I'll go through briefly in the video as well. And in the video today I'm just going to show you an example of setting up one capture area, but the principle applies for setting up two, for setting up three. If you want to game a domination with 3 capture areas you can do. Bear in mind the limitations that I'm going to explain to you. This is the code that will do that for you, fully working here for you today. So in this video we will be working with one single capture point, but at the end of the video you'll see an example of it working with multiple capture points. I am working on a little piece of code that will allow you to work with multiple capture points like domination if you can't work that out for yourself. But I really wanted to drop this video sooner rather than later, and we've been waiting for a long time for it already. So I wanted to crack on with it and get that out now. As always, if you enjoy the video, if you get something out of it, especially if you use the code, please do make sure that you subscribe to the channel, give me a thumbs up, and it would be really very useful to me, and I guess to everybody else that creates Portal mods, for you to share this video and show them this code so that everybody gets the chance to use it in their mods. It'd be really brilliant to see some fantastic experiences grow from this. Right, okay, so without further ado, let's crack on with today's video. So before we dive into the code, in the background you'll see some gameplay video. I did release this gameplay video about a week ago, showing the player moving around in a warehouse undiscarded, and you can see that well, it's tracking the position of the player. If they move inside the warehouse, you'll see that it says that they are in the secure area and moves the team 1 counter up to 1. If they move out of it, moves that counter back down to 0. You'll also see as they move around that there is a cutout bit of the warehouse that is not part of the capture area. That's just to demonstrate that the shape will be whatever you want it to be. You can cut bits out. You'll also notice as the player moves around, if they go up the stairs, that area is not included in the capture area, and you can define maximum and minimum Y points for the capture area to be included. So that's what we're going to go through today. We'll show you how to adjust the code and make this your own if you want to use it in your own experiences. So just to give you a little bit background into how this algorithm actually works, if we have a look at the Geeks for Geeks website, you'll see that they've got a little explanation of how to check if a point is inside a polygon or not. And this is the basis of our algorithm, but not the actual algorithm we use. I'll put the link in the description to this if you want to read it for yourself, but you can see we've got an inside example and an outside example. You can see the dot on the inside example is inside the polygon, and there's the dot on the outside. You can see there's some simple rules for us checking whether a dot or a point is inside the polygon, and it says draw a horizontal line to the right of each point and extend it to infinity. Count the number of times the line intersects with the polygon edges. Intersect just means crosses. If the point is inside the polygon, the count of intersections will be odd. That's basically it. So we can see these examples just underneath. If we use the examples of F and D, you can see F is inside the polygon, and we can tell that because if we draw a line out to the right to infinity, you can see it crosses or intersects with the polygon once. That's odd, must be inside the polygon. Same for D, draw the line out, intersects once there, that's it. It's got an odd number of intersects, it must be inside the polygon. And if we look at H up at the top and E, we can see that if we draw a line out from H, it has no intersects. That is even, an even number, so that is not inside the polygon. And we can see, well, the same rule applies to E, C and B, all the ones at the bottom. You can see if we look at E, we draw the line out from E, it crosses once, then it crosses again. So if you want to try this out for yourself, get yourself a piece of paper, draw yourself any shaped polygon, put a point inside and outside, draw a line across, and you will see that it works. Even if you've got some weird shaped polygon that zigs and zags, it will still work for any shape. That rule that if they're inside, you're going to get an odd number of intersects, and if you're on the outside, you get an even number. Now, the problem with Geeks for Geeks is they provide us with some code, but this code is actually too complicated for us to fit into the rules editor. If you're a programmer and you want to create your own little block of code, this is some really good examples in different programming languages. But if we wanted to transfer any of these over into the rules editor, they were just not really suitable. So that set me off looking for a better example, at which point I came across this one. So this article was point inclusion in a polygon test by W. Randolph Franklin, and it is their code that I have used and transferred into the rules editor. And the reason for that is if we look at the algorithm itself, excluding lines with only braces, there are only 7 lines of code. You can see that this is a very, very short algorithm. And for me, that made the most sense. It does have some weak spots, but to be honest, for our purposes, it serves those purposes absolutely perfectly. It counts the number of intersects. This one works slightly differently to the way that I have made it work in the rules editor, and I have made some changes to this to make it work with the rules editor. But in principle, if you're a programmer, this was the algorithm that I used. Doesn't need that many variables, and we can make it fit in the rules editor, and we can make it so that it's customizable for other people to use. Pretty easy stuff. So I'll put links to the Geeks for Geeks article, and I'll also put a link for the point inclusion in polygon test article by W. Randolph Franklin in the description for this. And if you want to have a read of this yourself, if you want to get a little bit further background and some descriptions, then these articles are for you. If you're only interested in getting the code and you want to see how to make it your own, then let's have a look at that now. So here's the code. Not too much to it really. It's a bit more complicated than most blocks of code that I've shown in my tutorial so far, and obviously there's a little bit too much to go through. You can just use this code and make the adjustments you need to yourself. I just want to show you a couple of the important bits. It's really more of an overview than anything else. You can have a look at it yourself at your own leisure once you are ready. This block of code at the top, this check inside area, this is actually W. Randolph Franklin's algorithm, but in the Battlefield Portal editor. The key part of the algorithm is actually this line here, and if we extend all the way across, you'll see that it's quite a long line. I'm sure I could probably get that a little bit simpler or lay that out a little bit more easily, but it worked for me, and that rule kind of does the job. So this block of code will count up the number of intersects on a polygon that it's being provided with for any given player. You don't need to alter this code, it will just work, and I'll show you how this works. Don't alter this subroutine at all, just leave it as it is. Down at the bottom you can also see I have extended this little bit. This is to take into account height. So you can see that we've got an if statement, and it basically says if the number of intersects is even, then set that player's in area variable to false. So just say that player is not in the area. Else, so that means if the number of intersects is odd, we're just going to check their height. And if it is in between the maximum and minimum Y values that we want, set that player to be in the area. Otherwise, set that player to be out of the area. But again, you don't need to make any alterations to that block of code. You can just take that subroutine, and I'll show you how that works in a moment. Underneath we've got this, and we're going to come back to this shortly because this is how we define our areas. You can see I've just put a little if statement in. We have a variable called secure area number, which allows us to select which secure area we want. Just let me get rid of these little blocks here because we're going to use those to set up another area in a moment. And we'll use that, or we can just alter this one here. This one here is the setup for the warehouse that I showed you earlier on. So you can see that we've got a minimum Y of 115, a maximum Y of 117. So it's got the height's got to be between 115 and 117, and then those are the coordinate points of every single corner point in that warehouse that we wanted to define as a solid polygon. We'll come back to that in a moment. There are a few additional subroutines just over on the right here. We don't need to make any alterations to these. We've got a subroutine that just initializes the number of players in the area. We're going to do that right from the start so we make sure that we're clear. So you can see we've got set variable number in the area for team ID 1 to 0 and set variable number in area for team ID 2 to 0. So that just starts off with a 0 value. So you're going to need a variable for number in area. If you just use the playground ID, you're going to get all this included anyway. Then we've got count players in area, and all this one does is it sets the number in the area variable for each team to be a count of the number of players that are on that team that have their in area flag set to true. Again, you don't need to make any alterations to that. That will just work. And then we've got display number in area. That's the little message that we've got at the top, and it will just show in there the number in the area for team 1 and the number in the area for team 2. So we've got just a few little subroutines that are going to be very useful for you there. We just move over to the right. We've got a bunch of rules. We've got an initial rule just at the top that sets the secure area number to 1, and if you remember earlier, that's our initial area. If we want to extend that, we can have additional ones. We've got to run the set secure area subroutine, and then we're going to initialize the number in the area, so that sets everything to 0. Just leave that as you want. You can extend that if you want. If you want to have a look, that's fine. So we've got this little rule here. It's an ongoing rule for the player that runs when the player is alive, and you can see that while that player is alive, if their in area variable is set to true, display in secure area and wait, and it's just going to keep looping. So every time that in area variable is set to true, it's going to display in secure area for that player. This is the important bit really, and you can see we've got a condition. This rule runs while the player is alive. While they are alive, run that check inside area subroutine, and remember that check inside subroutine is the subroutine that we had earlier that checks whether they're inside the area and sets their in area variable to true or false depending on whether they are, and wait a second. So it's just going to keep updating that throughout the game. So we've got this final little rule, update the number in the area. It's an ongoing one for everyone. And while the game mode time remaining is greater than 0, count the number of players in the area and display the number of players in the area. So it's just going to constantly update that. Now again, you might just want to spend a little bit of time looking at how all that works together, but if you want to adjust this to your own, you really want to know how to set the secure area. So the first place I'd begin, if I was you perhaps, is making sure that you make edits to this. So let's extend this and add ourselves on an additional secure area from the discarded map and see how this works. So I'm just going to move this to one side. I'm going to start off just layering these up. So we're going to get secure area 2. Let's just duplicate that min y value. Let's duplicate the max y value. So these are the minimum and maximum values for the position of the player to make sure that they're in the area. Then we are going to get this. So we need to set up the coordinates for the area that we want to check whether they are in. And then we'll just get one of these lines just here because we can copy it to our arts content. So I'm going to make this a simple-ish coordinate array, but you can set it up as complicated as you want. So the next thing that I'm going to need is the coordinates for this capture area, and I'm going to open up remote play in order to do that. I'm going to show you a simple way of getting the coordinates into Portal very quickly. So here we are, and I'm ready to find out what the coordinates are for my capture area. I've just spawned in a lat V. You can see the coordinates of the map where I am currently positioned in the top right hand corner. We did a little experience with this. We've got some code that shows you how to do this, and I'll put a link just at the top right hand corner so that you can get the coordinates yourself. So I'm going to take this vehicle over to the capture area that I want set out. Doesn't really matter where it is, we're just going to experiment a little bit, but I think that this area on the left will make a nice little capture point. I'm going to set ourselves up in this area. To make it a little bit more interesting, we're going to cut out the area to the right. You can see just here with that building. So it's going to be kind of a rectangular shape, but with that little building cut out to make it a little bit more interesting. So I'm going to head down to the bottom. You can see the coordinates at the top right hand corner changing. And this is the first coordinate that we are going to place into the rules editor. So you can see I've got the rules editor on the right hand side. It's not in the best position at the moment, I don't think, so I'm just going to move it around a little bit. I think what I need to do is just move the remote play window to the right a little bit so I can get that in a better position. And I'm going to move the portal editor, once I've got that in the right place, I'm going to move the portal editor over to the left, just so that I can get the coordinates off the screen at the right hand side at the same time as I'm putting it into the portal editor. Now obviously if you have your console close to your laptop or your PC that you're working on, that's not really necessary, or of course if you're doing this on a computer on your PC and you've got the windows side by side, that makes life a little bit easier, but for me this works, it's quite easy. So I'm just putting the coordinates now into the first section. You can see we put in the X coordinates and the Z coordinates that we've got from that corner. The Y coordinate isn't really that important because we're going to use the min and max Y values that we are going to define for the whole area anyway. So I'm just going to move over to the other corner of this particular capture area, so that we can get the coordinates for this corner. I can't get over there, I can't get quite into the corner. Right, I'm just going to take the coordinates from here. You can see I'm just going to duplicate this little block of code so that I get another coordinate. You could take it from the top if you wanted, but this one will do. And then we're going to record the X and Z values for this particular corner. You can see I'm putting in the digits up to 3 decimal points. You can put in as many as you want, but obviously the more decimal points that you put in there, the more accurate the coordinates will be. It's very important that we get these coordinates right and we don't miss any coordinates out of our polygon that we are setting up either. Right, I'm going to get in this corner here, just jump up on the bin so I can get the coordinate from that corner. And again, we've got a new X and Z position. I'll just duplicate that and put it in there. And you can see what I'm doing now is I'm working around each of the corner points of this polygon and recording, well, I said this polygon, the capture area, whatever you want to call it, and I'm recording the X and Z positions that are recorded at the top right hand corner. And that this is going to create the shape that we want to define. I can't get off here now, and I just need to get rid of that. So now I'm going to move over to this corner. You can see now this one's a bit more tricky to get because it's on the corner of the building, but this is approximately the area that I want. Again, duplicate this little block of code and put the X and Z values in for that one. Just take me a second while I type these in. And then once this is done, we are going to move over to the next corner on the other side of the building and record that one. Oh, just gone up the ladder. There we go. So we need this corner. So now we're cutting out the building. Now it's really important that you do not miss any of these corner points. You've got to really think about every corner that you want to define, every edge that you want to define. If you miss one out, obviously it just makes sense it's not going to work properly. So be very careful and methodical about working your way around the shape. I just put the Z value in for this corner as well. Right, we're not too far off now. We've got a few more corners to do. Let's take this one here. Just make sure I'm not too far out. There is a difference between just stepping out and stepping in. We're going to take this corner, which is just inside the capture area that I want set out. Let's duplicate that one and get that one in there, record the X and Z values. Right, not too far to go now. Let's get the values in there. Just get that sorted. Take a moment to type them in. What have we got? 491.010 and 440.275. Yep, there you go. That's in there. And then we've just got these final two corners to put in. Only take a second to put this one in there. I've just jumped up on the bin to make sure I get right in the corner of the capture area and record that one. You see this one's made up of a few sections, and obviously it doesn't really matter how many of these you put in there. I'm not sure what the limit is for the amount of data that you can store in an array, but they're pretty big. I'm sure you can put quite a few more of these in. Yeah, I'm sure you can put quite a few more of these in. Right, okay, so that one's recorded, and we're just going to go back over to the final corner. I've stuck again. Let's get that out of the way. Right, okay, so this is the final corner. Now, this is the last corner. We don't need to record that corner right over there in the corner because that was our original corner. So now, once we've recorded this one, we have recorded every single point on the polygon that we want to record to set out the capture area, and that will set in place that when we run this through the algorithm above, when you use the code to run it through the algorithm above, this will work. Right, that's it. We have finished with the catch points. Now we just need to figure out what our minimum and maximum height is. You can see at the moment it's set at 116. Well, it's 116.49, but if we set a minimum of 116, that seems reasonable enough. And then we're just going to move what would be a higher point. We could stand on here. Where does that take us? 116 would still keep us in there. I reckon that if I jump though, that would be a little bit higher. So we want a maximum height. Oh, I didn't mean to go over the fence there. Let's go back. That's quite high. Let's see what the highest point will be while we're still in this area. Let's jump on this bin. That seems pretty high. So we've got 117 now. Probably setting it at 118 or something like that would make sense. 119 might be better. I might go back and change it afterwards. We'll just run this through now. I might change it after I've tested it to see whether that works or not. And that's it. That is our area set up, ready for action. So here we are back in Portal, and you can see these are all the coordinates that we added for that particular capture area. You can see we've set the minimum Y to be 116, we've set the maximum Y to be 118, we've created an empty area coordinates array, and then we've added all of the corner points of the polygon to the array to set up that particular capture area. So that was our capture point 1, which was the one from the original video. You can see that's got quite a lot of coordinates in there. And then we've got this one, which is slightly less. We've just got a couple of final changes. If we want to use this as our secure area that we've just set up, we do need to change the other part of the code just up here where we set the secure area. So we've got, at the moment, it says set variable secure area number. We're just going to change that to 2, and that's it. So when the game loads, it's going to load the secure area values from that second section of that subroutine. So the secure area is now 2. So when it sets the secure area, we can see it runs this subroutine. If the secure area number equals 1, it's going to run that. Well, it doesn't now because we've altered it to 2. So it's going to load up these coordinates. That way you can add as many secure areas as you want. You can add as many capture areas, I should say, as you want. to call it secure area because that was the mode that I was creating. But you can create as many capture areas as you want. So you just have to define them in the array. You can obviously have multiple different capture areas if you want to. If you wanted to select a capture area at random, you could just have the secure area set by a random number. You know, if you've got 3 areas, select a random number between 1, 2, and 3. You could give the capture areas numbers in the game, and you could figure out which one the player was in. We'll maybe come to that later on, but for now, that's pretty much all you need. In the description below, you will find a link to the playground that has this particular code all set up for you to go. You just need to duplicate it. Once you've got the code, if you want to use this in your programs, all you have to do is figure out what the coordinates are for the area that we wish to define, and then have a good play around with it. So finally, just before we finish, it is worth pointing out the 4 tiny little drawbacks of this particular way of creating the capture areas. To most of you, these will probably seem pretty obvious, but I think I do need to make it clear so that we're all aware of what you can and cannot do with this particular method. So the first issue with this particular method is that the capture area will not be shown on the map. This isn't a replacement for a spatial editor. That really needs to come from DICE themselves. This is a way of implementing what hopefully they will put in the game at some point themselves. Anyway, the way that I've got around this in my particular mode is I have put direction indicators in the message boxes. You'll see that later on in the week when I release the video for my game mode, if I get that sorted this week. Really just some way of indicating which direction the player needs to go in. You can have a little think about that, maybe have a play around and have a think about how you're going to get the player directed to the capture area that you want and you have defined. Obviously, once they're in the capture area, they get the messages from my code saying insecure area, but they're going to need to know where that particular capture area is. So if you've got a game where the objective of the game is to capture a particular area, which really is probably what you want, and you've got two teams, and some of the players on that team are AI players, they won't go on their own to that capture area. They may well follow the human player, but they won't go to the capture area all of their own accord. They don't even recognize that it's there. Now, obviously, if you've set it up so that it detects players into the capture area, if the AI wander into it, they will start capturing that area. So it does work in terms of them being recognized by the code in the area. However, they don't see it. They won't make their way to it. And the third issue, and we've discussed this a little bit before, is that because there's no map ID block, so there's no code that will allow us to recognize which map has been loaded up, and because the coordinates are so specific to an area on a map, the coordinates will really only work with one map. So if you're setting this up, you'll set it up for a map, and that will be the map that is on your rotation. It will work with different sizes of the map if the area that you're in is in each size. So if you set it up for the small version of a map and then you load into the large version of the map, the coordinates
That's all you need
to
set
just
up your own
expanded.
capture
But
area.
obviously, because the coordinates are unique to a point on a map, and we can't recognize which map we are on without a map ID, it will only work for a single map. Hopefully a map ID will be coming, because that would be very useful for a lot of things. Now, that doesn't mean the code won't work on multiple maps, but it would have to be a single map per server that you set up. So let's say I've set it up on discarded for a particular game that I'm working on. You could carry over that code into another experience, so you could just use it again and put it on a different map and then alter the coordinates. I hope that makes sense, but like I say, it'll be one map at a time if you want to set up the coordinates, because it's specific to a map. That makes sense. Hopefully DICE will fix all that eventually. And the final one, it's only a small one, there are some edge cases just around the edge of capture areas where, because we're really just kind of getting rough coordinates from corners, it might not be super precise. To be honest, for the purposes of what we are using it for, I don't really think anybody would notice, but there might be a tiny little millimeter here or there where the capture area doesn't trigger until you've stepped over just that little part. But again, to be honest, I think that happens in the game anyway. We find little gaps in the capture area anyway. I think that those are small trade-offs for what is a very, very good method of detecting capture areas and working with them. And to be honest, hopefully DICE at some point will introduce a spatial editor. There's a desperate need for it, clearly. And if they do introduce that, maybe this code will be redundant by then. Obviously, if you've got any comments, if you want to share any feedback on this particular set of code and this video, welcome all your comments in my section underneath. I do try to reply to as many people as I can that leave the comments. I'm really hoping that you find this useful. As always, if you do find this useful, please click like and subscribe if you haven't already. I'm trying to work my way towards 1,000 subscribers. Slowed down a little bit recently, probably to do with the wane in popularity of Battlefield 2042, but I don't see that as an issue. Still think this is a great set of tools, still want to drive this forward, and if Battlefield 2042 does recover, as I'm really hoping it will do, then some of this stuff is going to become tremendously useful later on in the year. If you have any comments, please do leave them underneath. Welcome any comments from anybody. In the background at the moment, you can see I'm just making my way through that little secure area that we defined earlier. You can see that it's all set up now and working perfectly. You can also see if we enter the little building that's not part of the capture area. And there you go. That's how it works. Okay. I hope you found this useful. Until next time, later on this week, maybe early next week, I've got a cracking new mod for you all. Until then, speak to you later. Thanks very much.